Parallel lines. Proposition 3. If parallel lines are intercepted by a perpendicular line, then all angles equal 90 degrees. AB is parallel to CD. Line segment EF is perpendicular to AB. If line segment EF is perpendicular to AB, it is also perpendicular to CD. This symbol, two vertical lines, indicate lines that are parallel. A line that is vertical and horizontal, this symbol means perpendicular. If parallel lines are intercepted by a perpendicular line, then all angles equal 90 degrees. Proposition 4. If parallel lines are intercepted by a third line, which is called a transversal line, then all acute angles are equal and all obtuse angles are equal. Example, MN is parallel to TS. This is a transversal line. Angles 2, 3, 6, and 7 are equal. Angles, obtuse angles 1, 4, 5, and 8 are equal. If this angle is equal to 120 degrees, then all the other obtuse angles are also 120 degrees. This angle is equal to 120 degrees, this angle is equal to 120 degrees, and this angle is 120 degrees. If this angle is equal to 120 degrees, then this angle plus this angle is equal to 180 degrees because they form a straight line. Therefore, this angle is 60 degrees. If this angle is 60 degrees, then all the other acute angles would also equal to 60 degrees. This angle would equal to 60 degrees. This angle would equal to 60 degrees. And this angle would also equal to 60 degrees.
Angle problem solving. We get many prints like this in our company. And they don't give us the angles. They just say the holes are equally spaced. Now in this unit here we have 1, 2, 3, 4, 5, 6 holes. So what is the angle between these holes? So if there's 6 holes, you know one circle has 360 degrees. So we divide that by 6. 6 goes into 36. 6 times 0. So the angle between these holes is 60 degrees. Now why is that important? With our equipment, with our machinery, all our machinery moves in the X and the Y plane. And so if we want to put these holes into this part, whatever it is, we have to move in the XY dimension. Let's put 6 holes in here. We have to locate this dimension in the y-axis and also in the x-axis. Now we know, as we figured out before, this is 60 degrees. This is also between the two holes is 60 degrees. And so is this 60 degrees. That makes 180. So we have to know this location. Later on, when you take trigonometry, which is the next book after this, we'll be calculating the distances in the x and the y dimension. Right now we're interested in knowing the angles and why it is important. Our machines can only travel in the x and the y. Now the CNC machines, the computer numerically controlled machines, they can move simultaneously to this point, but they're actually moving in the x and the y. A manual machine, what you do is just crank the X handle, come over here, and then the Y handle, you get over here. Let's look at the next one. This has 1, 2, 3, 4, 5, 6, 7, 8 holes. So that's 360 divided by 8. 8 goes into 36 4 times. That's 32. That's 4 left over. 8 goes into 45 times. So we know the whole angle between the holes is 45 degrees. And here's a part that we actually machine in our shop. This has 8 holes, 1, 2, 3, 4, 5, 6, 7, 8. And we have to know the angles. We have to trig it out to find out what the dimension is in the X and the Y. I have one other drawing, and this is a flex element. This is a drawing of a flex element. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 goes into 360. It goes 36 times, so the angle between these holes is 36 degrees. Now there's something rather interesting about these flex elements, and we've made tens of thousands, probably hundreds of thousands of these flex elements. And as you can hear from the word, it's a flex element. It allows flexibility. And what they're used for, if you have a high-speed turbine and that's spinning at high RPM and it's driving a generator, what you don't do, you don't attach these two together with just 2 bolts, or just bolt them together. Because if there's any kind of wobbling or any kind of misalignment, it's going to shake the whole unit and damage it. So what they do, they put these flex elements between this here. And these flex elements are very thin. They're only about 10, 15, 20 thousandths thick, and they put a stack of them together. Now it allows some wobble. Now they want to make it as straight as possible, but allow some variance, some little wobble to take place without damaging the equipment. And as you can see from calculating these angles, we need to know them, because when they give us the prints, they don't give us the angles. They just say 6 holes equally spaced, or 8 holes equally spaced, or 10 holes, or 12 holes, or whatever they have, or whatever. It could be odd, it could be 9 holes equally spaced. We have to calculate the angles, and later on, as I discussed before, with trigonometry, then we find the X and the Y. And so you can see it's important to know your angles.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.